Alright, so this is for the Hadoop administration, right? So we'll understand. Yesterday also, once we had successfully set up the Hadoop cluster, I had shown you to create a directory and to upload, okay, just to test whether the setup is working well or not, okay. And those who have done it, it's working for them as well, right? It's working. You are able to create a directory, you are able to upload file, it's working for you as well, okay. So now let's basically understand. In Linux, basically we have whatever commands which we have in Linux, the same way we can follow in Hadoop as well, okay. So this is a good thing that you are already familiar with Linux commands, so it will be easy for you to perform Hadoop commands as well. In Linux we know that it all starts with slash, okay. The file system, if you see, it starts with slash, and under slash all the files and directories are present, okay. Similar way in Hadoop also, the hdfs directory structure, if you see, the topmost directory is slash, or we call it as root directory is slash only, okay. And if you want to explore the Hadoop directories, in that case what you need to write is, you need to write Hadoop fs -ls space slash, okay. So you have to write Hadoop space fs, then space -ls, then space slash, okay. So here ls command is same, and every time you will have to write Hadoop space fs, and with the command you have to write hyphen, that is additional thing, hyphen you have to write, and then I have passed slash. So inside my slash you will be able to see there are two folders. One folder is sample, another folder is mapred. Sample folder yesterday I have created, okay, in front of you I had created, okay. So these two things are there, and now here this Hadoop space fs, this is also depreciated, okay. So this was initially, if you see, all the commands were basically starting with Hadoop only, okay. All the Hadoop commands were starting with Hadoop only, but as soon as further developments were made, then they specialized, okay. For something they kept it as Hadoop, for something they come up with hdfs dfs, okay. So for hdfs you have two options now. One is Hadoop fs you can write, or you can write hdfs dfs, okay. So Hadoop fs is same as hdfs dfs, okay. So you can practice with hdfs dfs, okay. This is my suggestion, because hdfs dfs is basically made up for hdfs commands, okay. For certain others, for example, you want to submit a job, so there you can use Hadoop, okay, Hadoop, and then it's not fs Hadoop, then it is Hadoop jar when you want to submit a job. So job is basically nothing but a jar, so that is something which we later on will see, okay. So now you can always write hdfs dfs, okay, and then -ls and slash. So both the outputs of the both command will be same output you are able to see, right? So we'll be following hdfs dfs, alright. So as I told you, the directory structure is similar, like it starts with slash. The most important thing which you need to understand is that your Linux file system is different and your Hadoop file system is different. Many times it becomes a confusion that now this is first time you are basically exploring the hdfs, okay. And further, when you will be running some jobs, at that point of time, when I'll say, okay, let's have the file on hdfs, okay. So at that time you will not get it will not click into your mind that you have to basically upload some file into hdfs, and hdfs is a separate file system. You will directly put it under some Linux directory and you will say, I have the file but it's not working. So you need to understand that your Linux file system is a different one and your hdfs is different one, okay. If you want to explore hdfs, you will have to write hdfs dfs, and then you will have to write the command. If you want to explore your local file system, you know how to explore it. Directly ls and cd you can do. Cd, we basically navigate from one directory to another directory in local file systems. There is no mechanism yet present for hdfs. You cannot do cd for hdfs. This is another confusion many people get, okay. They say, I have done cd, I am in the same directory, and they say I am in the same Hadoop directory, but cd cannot be done for Hadoop, right? So don't get confused with local file system and Hadoop file system. Okay, fine. Now you already know how to create a directory. Sample is already created. Okay, so I'll just delete it and recreate it, so you'll get to know how you can delete. Okay, for delete we use rm command in Linux. The same command is used here. How you can use it? You can use it hdfs dfs -rm -rm and -r. -r is for recursive. Okay, recursive means if something is there inside the directory, that will be also deleted. Okay, so /sample sample. So now it should get deleted. Sample is deleted. Okay, now I'll run the command again, hdfs dfs -ls /. So I will get only one directory, that is mapred. So you are able to see only one directory, that is mapred. As I told you, the sample directory has been permanently deleted, but the ideal way should have been it should have gone to some trash, some recycle bin kind of thing. But there is no recycle bin concept yet implemented on HDFS, therefore it is completely deleted. We cannot recover it now. Okay, it is deleted. Fine. Now let us create a directory again, hdfs dfs -mkdir, and let us name it as SU, Sandeep University. Okay, so SU will be a directory created. Fine. So you are able to see now SU is a directory created. Right now, let me create some file on local file system. Okay, I'll do ls. So I'm under / I'll go into root, and here I'll create a directory mkdir, and I'll create a directory named as test. So test directory is created. I'll get inside test cd test, and here I'll create a file vi.a.txt. So I have created a file a.txt on local file system. Inside this I'll put some names. Okay, names. So I remember Darshan name, Darshans, and Saili is one name, right? Sorry, SAYLI, and no other name I remember. Yes, okay, I'll put two names only as of now. Okay, so I have a.txt where I have put two names. Okay, now basically I'll put it on SDFS. So for putting, I have a command SDFS dfs -put, and the source is a.txt and destination is /su. Okay, so inside SU, so SU is your SDFS and a.txt is your local file system. So just remember these things. Okay, these are small things that we forget. Enter. Okay, so this will get uploaded on SDFS under SU. So let us observe SDFS dfs -ls/su, enter. So here I should be able to get a.txt. Are you able to see? A.txt is there. Okay, now if I want to get the content, okay, content of a.txt, so what I can do is I can write SDFS dfs -cat. Cat is also a Linux command, right? So here also that works. Cat /su/a.txt. Now in local file system, tab works. Tab is very helpful, right? If you have a very lengthy name, you can press tab and finish it. But in SDFS it doesn't work. So the file is uploaded on HDFS. Okay, uploaded, and we are able to see the content as well. Fine. Now if I want to move this file from one directory to another inside SDFS only, so for that first I will create a directory and then I will move it. Okay, so I'll create another directory SDFS dfs -mkdir, and / I'll create a directory named as test here. So I have created a directory test. Now I will move that a.txt into test. So let me move it SDFS dfs -mv. mv is Linux command, as well as mv is for move, mv is for rename. For both purposes it is used. Now here I'll write / and after / I'll write the source SU and /a.txt, and then destination, that is test. So inside test, a.txt will get moved. Now let me check hdfs dfs -ls /su. So we should be able to find or not? We shouldn't be able to find. Yeah, so nothing is there inside su. But at the same time, if I write test, I should be able to get that a.txt. It is there. Okay. Now if you want to create a copy, so simply you'll have to instead of mv, you'll have to write the command cp. Okay, that will copy. Okay, so from test a.txt, I will copy it inside su. So copy will basically create another copy. It will not move, it will create another copy. Okay, now if I will do hdfs dfs -ls su, I should get that a.txt. Yeah, it is there. If you want to rename it, then what you can do is you can write mv only. Okay, you can write, instead of cp, write mv. So I am renaming a.txt to, let's say, data.txt. So it should get renamed from a.txt to data.txt. Test. Now I have data.txt, right? It is renamed. So here you are able to understand that whatever Linux commands you are using, they are same commands are being used. The way we are using the command, only the syntax changes. Okay, the syntax means sdfs and dfs and hyphen. That much is the change. Otherwise, the rest of the things are same. Okay, fine. Now basically moving towards the way you have put command. Similar way, there is a command called as copy from local. Okay, that is the same command. That is the same command like your put command. Okay, so let's say I want to I'll create something else. Okay, I'll create some other file. I'll create vi data. I'll create a file new names. Okay, .txt. So new names.txt. Now you can tell me your name. MRINAL. Okay, fine. Yeah, any other name? Yes, you can tell me. Okay, fine. Yours? Right? Okay. So this is a file with new names. Now the same command hdfs dfs, instead of writing -put, I can write copy from local. Just remember f and l is caps. New names, and I'll put it under test. Sorry. Yeah, so here basically what I can write, -ls -r I can write. Okay, so what -r will do? Recursively for every folder, each and every folder, it will iterate. Okay, so for basically our test, if you see, so under test we are able to see new names is being uploaded. New names is uploaded, right, for test. You're able to see that, right? Yeah, so this -r will recursively display the folders. Copy from local means from your local file system you are uploading your file on SDFS. Local file system. Your CentOS, yes. SDFS. Okay. Yes, SDFS is implemented on top of your local file system. Okay. Now you have only single node. If you will create another node, then your SDFS is implemented on top of your two different file systems, two CentOS, right? So it's a virtual layer which is created. Okay, it's a virtual layer which is created. Okay, fine. Now there is a command fsck that is to check the file system. Okay, so let me run that. hdfs fsck. Okay, so if we want to get the complete report of the cluster, what we can do is we can write hdfs dfs admin hyphen report, hdfs dfs admin hyphen report. So this will give us the report of the cluster. Report in the sense it will give us first aggregated report. So here if you see, yeah, this is the aggregated report, okay, of the whole cluster. Now the whole cluster consists of only one node, so aggregated report, and the report secondly it will give node wise report. Okay, let's say we have 10 nodes, so it will give details of 10 nodes. So this is aggregated, which says that the total configured capacity is 16.99 GB. So I had given 20 in total, right? So some part must have consumed in CentOS, some part must have consumed while downloading and installing the job tracker, and some part have been consumed by the JDK, right? So after that, whatever is remaining will be given to the SDFS. Are you getting this? We just discussed that SDFS is a virtual layer on top of your local file system. Okay, but it is a different layer. It's a virtual but different layer. Okay, so all the storage mechanism will be separate from your local file system. Okay, there will be no basically you can say some kind, you cannot store something on local file system and you will not be able to see in SDFS, and vice versa. That is not possible. They are two different systems. This is the space left out out of your this current node CentOS. Okay, and that is given to SDFS. So as you said, is this the space for SDFS? Yes, this is the total space which is given to the SDFS. Why? Because we have only one single node. Okay, and then basically here you can see data nodes available. So data nodes available, only one data node is there. If you have multiple data nodes, then what will happen? Like this one particular data node, which is named as master. In master only we have data node, name node, everything. Okay, so this particular data node's capacity is 6.99 GB, and that is basically given as a capacity of the whole cluster. If you would have two such data nodes, then 16 plus 16, it would have 32 or 33 GB we would have got here. Are you getting? So this one is aggregated report, and this one is one by one your data nodes report. So only one data node is there, so only one data nodes report we are able to see. Is it clear? Right? Yes. And as soon as you will add certain more data nodes, it will show here how many data nodes are there. If you have two data nodes and one is live and one is dead, so it will show one dead and one live, this way. Okay, so this is how you can get the report of your cluster. Right. Next, as I said, benchmarking of the cluster. Okay, benchmarking. I told you what is benchmarking? To get to understand how your cluster performs. Okay, so here in benchmarking we will create a directory. Okay, and that directory will be named as /benchmarks. Okay, so let us create this directory. I'll create it here, SDFS DFS -mkdir /benchmarks. So this directory will get created. Okay, done. And now basically we are given with certain jar files which already consist of a job. Okay, because after some time we will learn how to create a job as well. Job in the sense how to write a program. Okay, and once we create a jar of that program, that becomes a job for Hadoop. So already we have certain jars which will help us to test the cluster or benchmark the cluster. Okay, so there is a jar which is named as Hadoop test.jar. It is present inside userlib Hadoop. So we'll just see whether it is present there or not. cd /usr lib Hadoop 0.20 MapReduce ls. So here we are able to see certain jars are present. So the jar which is named here is Hadoop test.jar. I'll just try to check Hadoop test.jar. Yes, it is there. Hadoop test.jar is, yeah, it is there. It is present here. So we can use this jar. Okay. For using the jar, we should know that what kind of classes which are present inside the jar. We should have a knowledge of that. Okay. So here in the document it is already given. We need to write Hadoop jar and the jar name. Okay. So let us write that much. Hadoop jar. As I told you, if you want to run a job, you will have to write Hadoop then jar, because we submit a jar. We are doing SDFS operations, then we are writing SDFS DFS. Okay. So Hadoop jar, then jar name. Hadoop test.jar. I have written the jar name, and after that you have to provide the class name. So test DFS IO, this is the class name which is present inside that jar. Okay. So I will write test DFS IO. Test DFS IO. Okay. And then that class basically accepts certain parameters. So one parameter is write, number of files, and file size. So the operation will be writing the file. It will create dummy files. It will create dummy files and it will write on SDFS. Okay, and then test that what is the rate through which it is writing the files on SDFS. Okay, so write and then number of files 10, file size 10 MB. So 10 into 10, 100. Okay, 100 MB files will be generated. Okay, now so I'll just write these parameters. Write nr files, write nr files, so 10, and then we have file size as 10. So we need to write hyphen in front of them, hyphen file size and hyphen, okay, files. Enter. Now it will start generating some files and putting on SDFS. So some mistake in the command. In front of write also we have hyphen. Enter. Okay, so it has started. So now you see base directory benchmarks, it has gone up. Okay, so the directory which I had created, okay, that was benchmark. Inside that benchmark only it is working. So you can see here benchmarks. I had created benchmarks only. It has now started to create certain files. Total input paths to process, how many? 10. Why? Because I have given number of files as 10. Okay, it has started MapReduce job 20%. So let us open up a browser. Okay, and here we will write master 50070 and let's do the browse the file system, and we should be able to see that benchmarks and see test DFS IO data, IO control. So automatically it is creating the required files and it will upload the data as well. Map 40% completed, reduce 10%. It is calculating the rate at which the files are being written in the cluster. So at the end it will give us that throughput as well. Okay, map is 100%, reduce is 100%. Okay, so now here if you see number of files 10, 10, total MB bytes processed, okay, megabytes processed 100. Are you able to see 100? Okay, so 1 is coming there and 00 is coming down. Okay, and then throughput MB per second 8.64 MB per second, that is the throughput. Average IO rate, that is 11.18, okay, MB per second. Standard deviation, that is 5.14, and total test time, which is basically execution time, 91 seconds. Okay, so this is the benchmark of my cluster. So what is the use of this? I will basically record these readings and I'll put it into a document, and whenever we are basically running some jobs, okay, in future, and then if you find that your cluster is performing below this, then you can check that what is the problem, and if it is performing better than this, then you can update the benchmark. Okay, so what is the use of this? This is basically you are aware that what is the performance level of your cluster, so that let's say we want that these jobs should run in seconds, but it is not possible. You know that your cluster will behave this way, your cluster will perform or take this much time if you want to process something. You are already aware. Okay, so if some job comes and the requirement says that it should be done in very less period of time, you can tell them that is not possible because the benchmark says that your cluster will perform this task in this amount of time. Okay, are you getting? This is the benefit of the benchmark. Okay, and let's say if you have basically, it may happen that you are adding certain nodes to your cluster. So if you are adding certain nodes to the cluster, and then at that time you can again basically do the benchmarking. Okay, because if you are adding certain nodes, it might happen that your benchmark will change. It may become better or it may be getting down. Okay, both way it can happen. Alright, so the same way, the way I have written, the same way I have written the data in the cluster, I can read as well. Okay, I can read as well. Okay, the only difference will be instead of write I'll pass read. Okay, so here instead of write I will pass read, and same readings I can get out of that. And after that what I'll do is I'll clean the directory, because these are dummy files, that is junk data, that is not useful. Okay, so after this is done, I will clean that directory. Okay, so one option is that you can manually delete rm-r, hdfs dfs rm-r, or they have given already, this class has given a clean method, so using that you can delete everything. Okay, so this will also take some time. Okay, so lastly I'll just perform this clean operation. It will clean the directory. Okay, whatever junk files which are being uploaded, which are of size 10 MB each. You are able to understand till this thing, right? Okay. Yeah, almost done. Okay, so it is done. Fine, this is done, and here also we are getting the throughput. It's almost similar to the previous one, right one. And lastly, I can just clean that directory. I'll delete these parameters and I'll just write clean. Yeah, so it is just deleting the data inside that particular directory. Fine. And after that, now let us try to enable the trash. We'll come to this later. Yes. For enabling trash, you will have to add certain properties in your file, that is core site.xml. Okay, so you have a file core site.xml. You already have added certain properties there. So you just need to add some properties to enable trash. Okay, so here the property is fs dot trash dot interval, and it says 60. So 60 is the minute. Okay, that is the minute. 60 minutes will be the time. If you delete something, it will go to a trash folder, and that is for 60 minutes, and after that it will get deleted. Okay, and then basically there is another property, that is fs dot trash dot checkpoint dot interval. So there is a process which will keep on checking that if you have deleted some file, let's say now you have deleted some file, and then it should remain for 60 minutes only. So to check this, there is a process, okay, that this file is there in the trash for last 40 minutes. So after 20 minutes it should get deleted. So after what time this check should happen? Okay, so there is a property for that, and I have written 15 there. So after every 15 minutes there should be a check that whatever number of files are there, are they staying for more than 60 minutes, or still some time is required for them. Okay, so 15 minutes will be a check that if some file has crossed 60 minutes, it will be immediately deleted. Okay, so these two properties I will set in course site.xml. Okay, we have already seen that if we are deleting something, it is directly getting deleted, right? It is not getting inside trash folder. I'll just demonstrate that again. Okay, so let's say if I am deleting something, hdfs dfs hyphen rm hyphen r slash test test slash data dot txt, so it will directly get deleted. Okay, now after enabling, what will happen, we will see. Okay, here you can observe deleted test slash test data dot txt. Now let me get inside etc hadoop conf course site.xml, and here I'll add properties here. So this is one property I need to add. Okay, I have added the property. Okay, it requires value is 60 minutes. This is fine, and property. Okay, this is one property, and another is this one. Okay, so I have added these two properties. Now if I want to get the changes reflected, I need to restart the services. Okay, so this also you should keep in mind. I'll have to restart the services, because restarting the name node will actually, at the time of restart, it will refer these files again. Okay, now it is already started, so it will refer the old properties. So now you can just restart the services. So I'll just restart slash root restart.sh. So the services are getting restarted, then that property will get reflected. Are you getting this thing? Right, so whenever you are changing some XMLs, then you should ideally restart the respective properties. It is not required that I should start all the properties. It is not required. Even if I'll just restart the name node, that should also work. Okay, so let's say later on, if you are making some changes in another tool, like Hive is there, you're making some changes in the XML, then you should start only Hive related properties. Just restart them, then it should get reflected. Okay, so the last step is left out. and then just check by typing JPS whether all of them are running or not. Name node, secondary name node, data node, job tracker, task tracker, all of them are running, right? Now let us try deleting something, and what's happening, let's see. hdfs dfs hyphen rm, and let's delete a file under su. We have which file is there? a.txt is there, right? Let's delete that. Have you seen the difference? It doesn't say deleted, it says moved, where that a.txt is moved to trash at hdfs master user root dot trash current. Okay, it is basically moved there, it is not deleted. Okay, so this is a facility you can enable trash in your hdfs. Okay, now we can go and see there. Okay, so under browser we'll go to home and browse the file system. There's a folder user now created, a root created, and dot trash is there, current and su and a.txt. Okay, so if you want to put it back, so for that purpose the whole path is there, like under slash under su a.txt is deleted. So if you want to put it back, then you have to put it back under su, because I just deleted a.txt, but it has maintained that path slash su slash a.txt. So that basically will remind me that a.txt was present in su, right? So that way it is created. All right. And now if you want to basically directly permanently delete, like we do shift delete in Windows, okay, then in that case you can just pass this skip trash hyphen skip trash. So it will not put that particular file in trash, it will directly delete that file. Okay, so we already have something in, let's see, hdfs dfs hyphen ls slash test. So I think data.txt is there, or new data is there, new names is there. So if I want to delete hdfs dfs hyphen rm, and it is inside test new names dot txt, so I should write here skip skip trash trash, enter. So it should skip trash, deleted. Okay, the same we have got, deleted test names new names dot txt. Okay, so if you don't want that file to be put in trash, then you can follow this way. Okay, is it clear? Right? Fine. So you got the idea of how you can handle your SDFS. You can handle with the help of your command line, and you can handle with the help of your browser. From browser, what you can do is you can basically explore and download. We don't have, in this browser we don't have any delete operation, move operation, that is not here. Only you can explore. We are able to explore it and we are able to download it. If you want to download, then you can download. Under SU nothing is there now. Let's go to the parent directory. I think under test something is left out. No. So if you want to download here, you will be able to download something. MapRed system, let's see, something is there. Yeah. So if you want to download this, then download this file. You have an option, download this file. It is downloaded. That option is there. Okay. But you cannot edit or do something. And SDFS doesn't allow edit also. You must be aware by this time, right? It does not allow edits. You cannot edit anything. It is immutable. It is immutable. Okay. So you can just upload and keep on uploading certain new files. Okay, that is the purpose of SDFS. Okay, so I think for the admin part we are done.